Welcome back to the final part of this video. Today we're going to be talking about rationalizing denominators with binomials and radicals. To a lot of people, this seems like the toughest thing to do, and understanding conjugates is pretty useful, especially for standardized tests, so we're going to go over it. The main principle is derived from the difference of squares, and I will apply that in just a second. But this is the difference of squares. So you guys are probably familiar with foiling, a way to multiply binomials. And I'll go ahead and demonstrate that in just a second. So to FOIL, we're going to multiply the first terms and the outside terms. First, outside, inside, last, right? FOIL. You could also LOIF. The order doesn't really matter as long as you get all the pairs. So we have x times x gives me x squared, minus x times y gives me xy. Well, I also need to do the y times the x, or x times the y, to get positive xy, and then the y times the negative y to give me negative y squared. What happens here? Well, those cancel, the middle terms cancel, and I'm left with, let's change it to orange, x squared minus y squared. That is called the difference of squares. I should have used purple. That would have been super effective, but you guys get the point. So we get x squared minus y squared. Why is this useful? Well, we can apply it to normally terms that are not easily simplified. For example, here we have a conjugate of 1 plus the square root of 2, 1 minus the square root of 2. You'll notice that this is set up very much in the same way that the above problem was. We have a plus, we have a minus. We have a plus, we have a minus. And that's why these are called conjugates, because the first terms are the same, the second terms are the same, and the only difference is we have a plus and a minus in between. Okay, so we can go ahead and show what this does and why conjugates are effective and powerful in mathematics. So we're going to FOIL this again. So we have 1 times 1 gives me 1. 1 times negative radical 2, negative radical 2. Radical 2 times 1 gives me positive radical 2. Negative radical 2 times positive radical 2, negative radical 4. Let's simplify. The middle terms cancel out. This will always happen with conjugates. The middle terms will cancel out. And that's why it's so effective and why difference of squares is so important. So then we're just left with 1 minus radical 4, or 1 minus 2, which is negative 1. So conjugates help turn something that's complicated, i.e. these radical expression binomials, into something a lot less complicated when given the opportunity. So let's apply it with our one example here. I'm hoping this one example is so effective you'll know how to do it for all other examples. But the first step is identifying what is our half of the conjugate. Because you'll notice this is not multiplication at the bottom. It's separated by addition and subtraction. In this case, it's subtraction. So it's not as easy as just multiplying by radical 3 over radical 3. That's a very common mistake that I see, because that doesn't help you. The reason why it doesn't help is because you get something like this. Multiply by radical 3, you have to distribute. Boom, boom, shake the room. 4 radical 3 minus 3. Well, you still have that radical in the denominator, so it doesn't really help you that much. What does help is using the power of conjugates. So what do we need to do to make that into a conjugate? We have the minus, so we just need his buddy, the plus. Let's put this in parentheses, multiply it by his counterpart, his conjugate, 4 plus radical 3. For all the disbelievers, I'm going to show how this works in a second. Let's start with the top because it's easy. We have 5 times 4 plus radical 3 divided by, okay, so the top, we can distribute in just a second if you want. You can leave it, and I'll explain that in a second. But I'm going to show this multiplication first. So we have 4 minus radical 3, 4 plus radical 3, and we can FOIL it just like before. And once you've done this enough time, you can use your rules, but there's no harm in FOILing it each time for now. So we do 4 times 4 gives me 16. 4 times radical 3, 4 radical 3. Then we have negative radical 3. Let's change to, I think I used red before. Negative radical 3 times 4 gives me negative 4 radical 3. And negative radical 3 times radical 3 gives me negative radical 9. Just like before, the middle terms always cancel out. 4 radical 3 minus 4 radical 3, 0. 16 minus radical 9, 16 minus 3 equals 13. So there's a 13 that goes there. Now, if I want, I could distribute. Boom, boom, shake the room. I have 20 plus 5 radical 3 over 13. Final answer. I hope you found this video useful. I hope you guys have a better understanding of rationalizing denominators. And until I see you, be good, be kind, be true, be nice, and be honest, and have a wonderful day.